Hello guys, and welcome back to another video. Today we're going to try to find the derivative of this weird function here. As you can see, we have this weird exponent x to the x. So let's try to do it. Okay, so the first thing we could do is to apply the natural log function on both sides. So the natural log of y equals to the natural log of x to the x to the x. But the natural log of x to the x to the x is we can bring the exponent here to the front of the natural log, so we get x to the x times the natural log of x. So now we have this nice expression, natural log of y equals x to the x times the natural log of x. Okay, now we have this cool expression here, but there's another thing we have to do before differentiating both sides. We could apply the natural log again on both sides of the equation. So we have that the natural log of the natural log of y equals to the natural log of x to the x times the natural log of x. And we can split this natural log into two natural logs. So the natural log of x to the x plus the natural log of the natural log of x. And now we can bring this x to the front, so we have the natural log of the natural log of y equals to x natural log of x plus the natural log of the natural log of x. And now guys, we can take the derivative on both sides, so d over dx on both sides. And here at the first member we have to apply the chain rule twice. So we're gonna get the derivative of the natural log of y is 1 over the natural log of y times the derivative of the natural log of y, so 1 over y times the derivative of y with respect to x, that is dy over dx. So yeah, we apply the chain rule 2 times, and all of this stuff equals to the derivative of x times the natural log of x. So we can just apply the product rule for derivatives. So this is going to be the derivative of x is 1 times the natural log of x, so it is natural log of x, plus x times the derivative of the natural log of x, that is 1 over x, and then we have plus the derivative of the natural log of the natural log of x, and here we have to do the same thing we did earlier, so this is just 1 over the natural log of x, and then by the chain rule we have times 1 over x. Okay guys, we're almost finished. Let me move this equation here so we have some space to write down all this stuff. We can now isolate dy over dx because this is what we're interested in, dy over dx. So dy over dx equals to, well, just multiply both sides by natural log of y times y, and we get y natural log of y times natural log of x plus x and x, we can simplify them, and it is just 1 plus 1 over x natural log of x. All right, now there's another thing we could do, and we can basically rewrite these as y natural log of y, and then we can just sum up all of these terms so we have at the denominator x ln of x. Here we have x ln squared of x plus x ln of x plus 1. All right, now there's another thing we have to do to get our result. We just need to substitute instead of y our function x to the x to the x, because y equals x to the x to the x. So let's do it. We have x to the x to the x times the natural log of always x to the x to the x, and then we have times all this stuff here. So x ln squared of x plus x ln of x plus 1 over x ln of x. And okay, let me clear this so I can write everything bigger. So this equals to, we always have our x to the x to the x, but then natural log of x to the x to the x, same thing. This is x to the x times the natural log of x, and times x ln of x, and always all this stuff. So x ln squared of x plus x ln of x plus 1. And as you can see, we can just simplify the natural logs, and what we get is the following: x to the x to the x times x to the x times natural log squared of x plus the natural log of x plus 1 over x, and we are done. Alright, it was tough, and yes, it would be cool to differentiate this function, but we're not gonna do it now. And if you enjoyed this video, leave a thumbs up, subscribe to my channel, share this video with your friends, and as always, until next time, bye.